Hello. In the previous video, I explained how to calculate the correlation coefficient and what's the difference between covariance and correlation coefficient. The idea is covariance captures the direction by its sign, but correlation coefficient captures the direction and the strength at the same time. And then our next question is, consider this example. We have 5 macroeconomic variables from many years, and the variables are the most famous, more commonly used variables in macroeconomics, like GDP growth rate, industrial production growth rate, CPI inflation rate, so consumer price index inflation rate, unemployment rate, and 10-year treasury bill rate. So they are observed quarterly. Each quarter we collect 5 key variables, and we would like to analyze their relationship, the relationship among 5 variables. Can we extend covariance or correlation coefficient to more than 2 variables? The answer is no. Correlation coefficient and covariance are only for one pair of variables. When you have 5 variables like this, there is no direct way to analyze them using covariance or correlation coefficient. Instead, what you have to do here is you have to study every possible pair. So calculate the covariance for every possible pair of those variables. Like, for example, you can calculate covariance between GDP and industrial production growth rates. Or you can calculate the correlation between GDP growth rate and CPI inflation rates. Or like any pair, you choose any pair, then you can calculate covariance. In that way, we are going to make a table. It's a matrix or a table. So there are 5: GDP, industrial production, inflation, unemployment rate, treasury bill rate. There are 5 variables and 5 variables, and each cell is one pair. For example, 0.18 is for the pair of treasury bill rate and GDP growth rate. So when you choose this guy and this guy, you have to look at this. On Excel, I'm going to demonstrate this on Excel. So real data, I'm using the real data. So we observe from 1962 every quarter, January, April, July, September, October, and up to the 4th quarter of 2015. And there are 5 variables, as you see. And what we are going to do here is we are going to use data analysis. Data analysis has some options. If you click this, then you have some options, and we are going to use covariance. Later, I'm going to show you how to use correlation. But covariance, click covariance, and input range is from here to here. 5 variables and first labels in first row. Click. Then you have a table. This is exactly what I have in the slides. So for example, 10-year treasury bill rate and real GDP growth rate have a covariance of 0.18, right? Go back to here. So simply the same numbers. So this table is called the covariance matrix or covariance table. Or like for example, I'm asked if you choose any number like minus 2.42, then it is inflation and industrial production. So they have a covariance of minus 2.42. Okay. And then what are these diagonal terms? If you think about 11.33, it's covariance between GDP and GDP, which is the variance of GDP, right? GDP growth rate. So the diagonal terms are variances, because variances are special cases of covariances. So you can interpret the diagonal terms as variance. And off-diagonal terms are the true covariance capturing the relationship between two variables, right? And then let's just read it. Let's just interpret what's going on. So look at the first column, GDP. I'm going to drop the variance. Variance is not much of interest. So GDP has 4 covariances with other variables. Among them, 2 are negative and 2 are positive. So when GDP growth rate increases, when the economy is going well, industrial production would be positive, like have positive relationship. Industrial production would be increasing, and inflation would be increasing. That's what we learned from macroeconomics, but it is negative. So there is a red flag here. And when the economy is going up, unemployment rate will drop. So it's negative, correctly negative. And when economy goes up, the interest rate will go up. So it's also positive. So this is how we interpret, how we read the result. Then why is it negative? That's the research question and a very important question in macroeconomics. I'm not sure if you learned maybe expectation adjusted, expectation augmented inflation rate, or Phillips curve is one possible way to explain the negative relationship. So of course economists in many years ago, like in the 80s, wondered why the pattern is negative, why the relationship is negative, and they developed many theories to explain that. And when I was a college student, I learned that one of the most compelling explanation was the expectation augmented theory. People not only consider the inflation as it is, but it's up to their expectation. If they expect the inflation to be 10% and then observe actually it was 9%, then you have to treat it as a decrease in inflation, something like that. Anyhow, I'm not teaching you macroeconomics, but anyhow, we may interpret the covariances directly from the table. However, as I said before, the magnitude of the covariance has no meaning. You cannot compare that. So for example, industrial production's covariance, from the perspective of GDP, industrial production's covariance is 7.66, but treasury bill rate is only 0.18. But you cannot say industrial production's covariance is greater than the treasury bill rate. That means nothing. So you cannot compare them. You cannot say this is stronger than this one. You cannot compare at all. That's the problem. Problem of covariance. So be careful. Just what you can read from there is the signs. Oh, by the way, even if I'm saying as if the covariance's magnitude has no meaning, yes, they have no meaning. But later we are going to use covariance for other cases, for other contexts. So wait until the next lecture. Then you will see why covariance is more important. Why we study covariance even if it looks nothing, like not important at all. Anyhow, you cannot compare the magnitude, the absolute values. So then what do? We make correlation coefficient calculate correlation coefficient from the covariance. And you can do that directly from this table because you know everything. Can you imagine? Can you try this question? How can you infer about the correlation coefficient between inflation rate and unemployment rate? 3, 2, 1. So the answer is D. First, remember, the correlation coefficient is covariance divided by standard deviations, 2 standard deviations. So first, covariance is obviously unemployment rate, inflation rate, and their covariance is 0.48. So it's easy. Now you have to put standard deviations in the denominator, and the standard deviation is not given in this table because the diagonal terms are variances, not standard deviations. So you have to take square root of them. So 8.26 is the variance of inflation rate. So if you take its square root, then you get the standard deviation of inflation rate. Similarly, square root of 2.57 is the standard deviation of the unemployment rate. Use them, the square roots, to standardize correlation coefficient, the covariance, to obtain the correlation coefficient. The answer is D. So in that way, you can make here is the formula. So it is easy. Then after the algebra, you will get 0.1 something. So in that way, we may calculate the correlation coefficient matrix, which is just updated version of covariance. And as you can expect, we may use correlation method, correlation tool. Click OK, and input range is the 5 cells labels. Okay. You have a new matrix, but it is now correlation coefficients. They are correlation coefficients, not covariances. So as you see, it's standardized. So the diagonal terms are 1, all diagonal terms are 1, and off-diagonal terms are smaller than 1, between -1 and 1, -1 and +1. So the table is here. And now I think it is easier to interpret. So the diagonal terms are the correlation coefficient of themselves, should be 1. So correlation coefficient between GDP and GDP should be 1 because they are perfectly correlated. They are equal. So they are perfectly correlated. So their correlation coefficient should be 1, right? And then industrial production and GDP has positive correlation coefficient 0.49 and minus 0.21, minus 0.10, and 0.02. So the non-diagonal terms are pairwise correlation coefficients. And now you can compare the magnitudes, the strength of the relationship. For example, the correlation coefficient between GDP growth rate and in the industrial production growth rate is 0.49, which is greater than the correlation coefficient between the GDP growth rate and the treasury bill rate, 0.02. So compare this guy and this guy. So from this table, you can say that in our framework, GDP is more closely correlated with the industrial production than treasury bill rate, right? Makes sense. And then let me ask you this question. Which pair has the strongest negative correlation? That's easy. Try this. 3, 2, 1. I think among the negative ones, there are only 5 negative numbers. And of course, obviously, minus 0.36 is the most strongest negative correlation. So it is between unemployment rate and industrial production. The answer is C. So now you can compare the absolute values or the signs. By the way, when I say strong to the negative side, closer to -1 is stronger, right? The closer to -1, the stronger the correlation is. So 0 has no relationship. Weakest relationship is 0, and as it goes away from 0 to +1 or -1, the relationship becomes stronger. And that's how we interpret this. Okay, this will do the video, and I'm going to consider more interesting example of financial investment diversification in financial portfolio. using correlation and covariance theory. So see you on Thursday. Bye.